This is exercise 124 of chapter 4 in our textbook, where we're told that a box contains 25 parts, of which 22 are non-defective. If 22 of those 25 are not defective, then it makes sense that the remaining 3 are defective. If 2 parts are selected without replacement, that is key in this problem. Without replacement means we did not put them back after we drew the first one. Find the following probabilities. First, in A, find the probability that both are defective. Now, whenever I'm dealing with a probability question that involves non-replacement, I often consider whether or not it might be helpful to draw a diagram like a tree diagram. And I think that will be helpful in this case. So the first part that I pick has one of two options. Either it is defective or it is not defective. And we know that the probability that it is defective would be equal to 3 out of 25, because only 3 of the total number in the box are defective. And we also know then that the probability that that one we pick is not defective would be 22 out of 25. And we notice that those probabilities that stem from the same place in our tree diagram add up to 25 out of 25, which is equal to 1. That's the first part that I pick from the box. But then I'm going to pick a second part, and I'm not going to replace the first one that I picked. So part 2 may again be either defective or not, whether the first part I picked was defective or not. So my tree diagram continues on as you see here. I have to remember now, though, I picked a part and I did not replace that part. Therefore, there are only 24 parts remaining in the box. Now, this stem here that I'm continuing on with in my tree diagram is one where I want to determine the probability that the second part I pick is defective if I know that the first part I picked was defective. So one, I did not replace the first part in the back in the box, so that's why I only have 24 parts remaining. Of those 24 parts, only 2 of them are defective because I already picked one of them, leaving me with only 2. That means then that of the 24 parts remaining, if 2 of them are defective, then the remaining 22 are not defective, which makes sense. I started with 22 parts that were not defective. I did not remove any non-defective parts from the box, and therefore I still have 22 parts that are not defective. So the probability the second part is not defective is 22 out of 24. Now, if the first part I picked was not defective, and I didn't put it back in the box, then the second probability that the second part is defective would be 1. I have 24 parts remaining in the box, 3 of which are still defective because I did not remove any defective from the box. But if the first part I picked was not defective, and I want to know the probability then that the second part I pick is not defective, of the 24 parts that remain in the box, only 21 of them are not defective because I removed one of the 22 already. So let's look at what we've got. Our first set of branches, we have a double defective. Both parts were defective. Our last set of branches, I have a double non-defective. Both parts were not defective. My middle branches are a combination of a defective and a non-defective part. So to find the probability of both being defective, I'm going to need to take 3 over 25 times 2 over 24. That would be equivalent to 3 times 2, 6, over 25 times 24, 600. The probability that both are not defective would be the product of the blue probabilities. 22 times 21 is 462. 25 times 24 is 600. The probability that one is defective and the other is not would be the product of the middle branches. If the first is defective and the second is not, that would be 3 times 22, or 66, over 25 times 24, 600. If the first was not defective and the second is, the probability would be 22 times 3, or 66, over 25 times 24, 600. Now I want you to note that if you add these probabilities, 6 over 600 plus 66 over 600 plus 66 over 600 plus 462 over 600, they add up to 600 over 600, which is 1. That's one of our properties of the sample space of probabilities. They must always add up to 1. So now in question A, what's the probability that both are defective? That, of course, is my double D. 6 out of 600, which I could reduce to 1 out of 100 if I wanted to, which is equivalent to 0.01 or 1% chance. In B, what's the probability that exactly 1 is defective? Exactly 1 being defective would be the sum of these two probabilities, because either the first was defective and the second was not, or the first was not defective and the second was. With or, we know to add probabilities. So this would be a 132 out of 600 probability. In C, what's the probability that neither is defective? Well, that would be my double N. So that would be my 462 out of 600.